Hello, assalamu alaikum. Hello.
Hey, salam alaikum.
How are you?
Alhamdulillah, I'm doing great. You?
Alhamdulillah, I am fine. Okay. So we will start our today's class. So mainly from this class, we also try to discuss about the image classification for making the land use land cover classification. This part I will try to complete, and we also try to show you that all of the process how you can easily use the different types of machine learning for making the different types of land use land cover classification map using the Google Earth Engine platform. Okay, so let's go.
Nice.
So I simply share my screen. Can you see my screen now?
No.
Yeah.
Yes.
Okay. Okay, so let's go. Okay, so let's go to this class. So hi and welcome to the 7 days online training program. Today we will try to discuss about the land use and land cover classification using the Google Earth Engine platform. So basically, today I will try to discuss about all of the course content. So such as just a minute, some problem in my slide. Okay, okay, so now it's okay. Okay, so now, today I will try to discuss about this part, all of the course content. So how you can easily make the land use land cover classification map using the Google Earth Engine platform, and how to make introduction to land cover classification map in Google Earth Engine. Then how to export this map as a TIFF format, and then calculate the area of each classes after completing the classification. You also need to calculate the area, such as how much build-up area is available for your region, how much water body, how much vegetation. So you also need to calculate it all of the classes. Okay, and then we also need to take the accuracy assessment of the land use land cover map. What is the accuracy? We also try to show you that how we can easily create the single class levels map. So first of all, introduction to land use and land cover classification map. So mainly land use and land cover. Land cover is it's defined the natural feature on the earth surface. It can be different types of only for the natural features, such as ocean, such as we can also say that this is the one kind of trees, okay, as well as also hill. So these types of natural feature is identify the land cover. And land use mainly human induce the land, okay, such as settlement, built up area, then road or crop agriculture land. Okay, so it's type of the land use, and it is the land cover can be defined as the observe the biophysical cover of the earth's surface, and it indicates the physical land type such as forest, open water, where the land use document how people are using the land. So it's the land use. By comparing the land cover data and maps over a period of time, we can document land use terms and changes. We can easily do this. And in this time, we are using the Google Earth Engine platform for making the land use and land cover classification map for identify the different types of feature on the surface. So basically, we just follow the some step. Then we can easily get this land use land cover classification map in Google Earth Engine platform. So our first step is that you need to selecting your region of interest. Suppose you want to need the map, land use land cover map for Dhaka city. So you need to import your Dhaka city shape file. Okay. Suppose you need to land use land cover map for the Bangladesh. So you can simply put your Bangladesh country boundary shapefile. And then you need to choosing and filtering the image collection. Such as suppose you want to work with the Landsat or Sentinel, then you can simply choose this image collection and you need to filter this image collection according to your region, according to the image properties, according to your time period. You need to filter this image collection. Okay. Third step is that you need to collecting the training point. So you can simply collect the training point from the satellite images for the different types of feature. Suppose you can take the training point for the field of area. You can take the training point for the water body. You can take the training point for the vegetation. You can take the training point for the barren land. Okay. So you need to collecting the some training point. Okay. After this training point, you need to merge all of the training point together. You merge all of the training point. And then using this training point, you need to make a training data set. Okay. So mainly this training data set, it provide you the spectral signature. So different types of band, we are also need to add here the prediction band. Suppose B1, B2, B3, B4 or all of the prediction band we add here. So in this time, my main target is that I create the training point, I get the all of the training point band pixel value. Okay, so I want to get all of the band pixel value. And it's called the training dataset or spectral signature. I create the spectral signature for all of the training point. So it's my dataset. Then this dataset I need to classify. Okay, this dataset I need to classify using the different types of classifier. It can be random forest. It can be decision it can be classification and regression trees. It can be minimum distance. So lot of classifier will be available here in here. So after when you can get the training data set, this training data set you need to classify using the classifier. In this time, this classifier can be different classifier is available in Google Earth Engine platform. Random forest, minimum distance trees, then classification and regression trees, support vector machine. Okay, you can use the classifier and classify the image and create the classified image. Okay, applying the classifier. Then you need to display the result. You can show the result. Okay, so all of the result we can easily show. This is the build-up area, this is the vegetation, this is the barren land. We can easily show the result, our LULC map. After this, we need to calculate the specific area of each classes. How much build-up area is available for this region? How much vegetation is available for this region? And we also need to calculate the accuracy assessment of this map. What is the accuracy of this map? We also need to calculate it. Okay, so here you can see the small project of LULC map using the Google Earth Engine platform. Okay, this is the code link. Also, you can see this is the Dhaka city LULC map. When we are classifying the field of area, water body, vegetation, and barren land. And then we also calculated the area. Like this area, we need to calculate it. And we also you can easily make that this chart, bar column chart in Google Earth Engine platform after calculating the area for our presentation work. Okay, so in this time I try to show you this one kind of project, how you can easily do it practically. Then I hope you can easily understand. So I just simply open my code editor and try to show you all of the process step by step. So just I simply open my code editor. Okay, so first step is that I need to import my shapefile. So it's very easy. I simply go to the asset. Here I already import my shapefile. So suppose in this time I want to work with the Dhaka city. I simply import the Dhaka city shapefile in here. I simply change the name. Suppose this is that ROI. Okay, you can put any name. In this time, I just simply show the layer. I simply use here the map.add layer function, and then I simply call the ROI. I click to the run. I did not see the Dhaka city. In this time, I also need to focus the center. I simply use here the another function map dot center object with ROI and assign the value suppose 10 and click the run. Okay, so you can see I can get my region. Suppose this region I want to create the land use land cover classification map for any specific time period. Okay, so I can get my region. Okay, so this is my first step, selecting your region of interest. In this time I go to my second step. My second step is that I need to choosing and filtering the image collection. So in this time I want to work with the Landsat 8 images. So I simply go to the browse data catalog and try to find out the Landsat images for Landsat. I want to work with the Landsat 8. I want to work with the top of atmospheric images. So I simply click here. And then first of all, this is my image collection. And I simply copy this line of this code from here. I simply copy because I need to import the image artisan snapper in my code editor for importing the image collection. Simply import and I simply put the variable name, suppose L8. Okay, I simply put the variable name is the L8. So now I just filtered this image collection. Okay, and we already covered this part, how you can easily filter the image collection according to your region, according to the time period. Okay, we already covered this part, so I also write the code again. So in this time I just simply import this. Okay, so I just simply take a variable, suppose this variable name is the image. Okay, so I simply call my full collection L8 and I simply put here the filter bounds function. So mainly filter bounds, it's intersecting with your whole collection with your region of interest. So in this time my region of interest is that ROI. Okay, then I simply use here the another thing is that suppose I simply use here the specific time period. I simply use here the filter date, and I simply put here the start date and end date. So I simply put here the start date is that suppose I want to make the map for 2021. Okay, I simply put the 2021 and put here the end date 2021 December 31. Okay, in this time you can check I want to need only for this image, which image will be not more than 1% cloud cover. So I simply use here the filter metadata and I simply put here the cloud cover image properties name. I simply put here the less than 1. Okay, so now I want to check how many images available in from this. I can simply use the print function and simply call the image and use here the size function, and now it provides me, you can see how many images available. 4 images I can get the for this region. Here I can get total 4 tiles. Okay, so in this time if you want to work with the single image, I already show you this part our previous classes. In this time I want to create the median composite for all of the 4 images and make a satellite image in here. So I simply use a function, it's called the median function, and then finally it's clip with my shapefile. So I simply clip with this shapefile is that ROI. In this time I just simply show the result. So I simply use the map.add layer and I simply call the image and click the run. So now you can see it's showing our satellite images in for the Dhaka city year of 2021. Okay, but this images look like this because I did not add the visualization. So in this time I simply add the visualization. So I just simply click here and then I simply add here the band. So I add B4, B3 and B2. It's called the true color composite. So mainly true color composite, human eye can see. Okay, it's look like this. I simply use here the 98% for better looking, then apply. So now I can see I can get the satellite image look like this. Okay, So this is my satellite image. So in this time, this satellite image I want to use for making the land use and land cover classification map. Okay. So in this time, my I simply import. You can see click to the import. When I click to the import, you can see new line of code would be added here. I simply click to the import. You can see I simply copy this name, and we already know about that. After the visualization parameter, we always put here the object name. So this is the object. After the object, we need to put here the visualization variable name. I simply put here, and then I simply put the layer name. Suppose true color. Okay, then click on. So now it will be okay. You can see. Okay, something wrong. Okay. Okay. So now you can see it added this color fix. Now I can get the true color composite in here. So this is my second step, choosing and filtering the image collection. I choose the Landsat 8 and filtering the image collection according to my time period, according to my requirement. I need the image for the less than 1% cloud cover. Okay, I can get the satellite image. In this time, I move to the third step. My third step is that in this time, I need to take the some training point for each classes which I need to classify. Okay. Okay. So in this time, we are use here the different types of process for taking the training point. Okay. So I have to try to show you all of the process. How you can easily identify this is the water, this is the build up area, this is the barren land. How I can get easily, because I already know stay in the Dhaka city, and I also know better than you because I already stay in Dhaka. And I know all of the things where I can get the water, where I can get the vegetation, where I can get the barren land in the Dhaka city. But as a unknown place, when you want to make the land use land cover classification map, so it's a very difficult to identify the feature. So then we also use here the different types of band combination. Okay. So when you use the different types of band combination, these different types of band combination you help you to identify the different types of feature on the surface. Suppose I did not go the Italy, but I need to make the land use land cover classification map for the Italy. I don't know the better place where I can get the water, or where I can get the vegetation, where I can get the barren land. I don't know. So then I follow the process for band combination. I use here the different types of band combination and identify the different types of feature on the surface. Okay. So in this time here you can see here I use here the different types of band combination. Suppose you can see true color composite. When I use here the true color composite, then I can get this band image look like this. But when I use here the B5, B4 and B3, it's I simply use here the 98% and click to the apply. So now you can say I can get this image look like this. Okay. So in this time I can get this image look like this. And when you are using this band combination, it identify the red pixel value, the better red pixel value identify the better vegetation. Okay. Dark region, this dark region or black region identify the water body. Okay. So then also you can see that this type of the white color, it's identify the build up area when I use the band combination. So this it's constant. So any place, suppose you want to apply this band combination for the Italy. So here you can easily find out the Italy water. You can see this water is the black color. This better vegetation, it's look like the red color. Okay. So and suppose I want to use another. Suppose you can see I use the 6, 5, 3 and apply. So now you can see in this time it's identify the barren land. You can see we can easily identify this type of, it's called the this type of color identify the barren land, and you can get all of the information from the website. I also provide you the website. So this website is that you can see. So and set. Okay. So this is the website. Here you can get all of the information about the band combination. Which band combination which provide you the different types of feature. Suppose you can see natural color 432. So red, green and blue. This is natural color. It replicates the close to our what our human eyes can see. Okay. So healthy vegetation is green, unhealthy flora is brown, urban feature appear the white and gray, and water is the dark blue or black when you use this band combination. Okay. So this is the one kind of band combination, true natural color. Also you can see color infrared 543. It is also called the false color composite. When you use the band combination, it's the 5 is the near. Then also you can see red and green. Okay, so when you are using this band combination, mainly it's useful for analyzing the vegetation. Okay, and it areas red have better vegetation or healthy vegetation. When I can get the red, it's identify the better vegetation or healthy vegetation. And dark areas, you can see dark areas are water, urban areas are white, look like this color. Okay, also you can see this is a short wave infrared. So when I use this band combination, then I can get this types of the feature easily identify. Okay, also you can see this the when you want to classify the agriculture field, agriculture, so then we are need to use here the band combination 652, short wave infrared 1, near infrared and blue. So it's mainly used for the crop monitoring. Okay, and healthy vegetation appears the dark green. Okay, so here using this, and other you can see this type of the barren land, we can get this type of color. Okay, this is the magenta hues, we can get this color like this. Also when you want to identify the geological feature, so then you use here the geology 762. Okay, so lot bathymetric, so lot of band combination used for different types of feature on that surface. So you're also, I have to send you this link so you can easily go all of the things from here, and you can easily use this knowledge and you can easily get the training point from here. Okay, so using this process, we are get the any types of any place where which place you did not visit any time. You can easily make this place for land use land cover classification map using the band combination, because when you are using the different types of band combination, we can easily identify the different types of feature on the surface. Okay, let's go. So in this time, we can easily identify the drag area. Drag area is that we can easily identify the drag area is the water. Okay. So in this time, I take the training point for the water. So I simply click on here as a marker. Okay, then I simply click to here and put the name suppose as a water. Okay. Then simply put here the feature collection and property name. Property name will be same for all of the classes. So I simply use here the class and set the value for the 0. Okay, so you can see I simply put the name water. It can be any name, no problem. I take the training point for the water. I simply use here the water. Then class is it's also as a variable. Okay, so I use here the class, no problem. If you want, you can use the another name, no problem. And set the value for the water training point. I set the value for the 0. Then okay, so now I can see it set the water. Okay, I simply click here. You can see now it will be bold letter of water, and I simply press on the water, so I get the training point for the water body. So I simply take the training point for the water body. Okay, so I take the training point, look like this. In this time, so I take the another training point. I simply click on the new layer, then click to here. In this time, I take the training point for build up area. So I simply use here the build up. Okay, then I simply use here the feature collection. Property name will be same. Property name class is the same class, and set the value for the build up area 1. Okay, so I simply use the okay. And this feature, this band combination is not provide the build up area easily. I use here the natural color. So 4, 3, and 2, and apply. So now you can see I can get this result look like this. Okay, and there's a lot of build-up area in this here. So I simply take the build-up area, build-up training point. I take the training point for the build-up area. In this time, I take the training point for the vegetation. I simply click here and then again put the name vegetation. And I simply feature collection property name will be same for class, and value 0, 1, it's 2. Okay, so 0, 1, 2. In this time I use here the 5, 4, and 3. 98% apply. So now you can see the red color is identify the better vegetation. So I simply take the some better vegetation from this red pixel value. So I simply use this training point from this region because the better red identifies the better vegetation. Okay, so I simply take this training point from here. Okay, then I take another layer. In this time, I take the training point for the barren land. So I simply use here the barren land, and then I simply use there the feature collection. And now I simply put the name as the suppose class, and put the value for
What
0, 1, 3.
what is the difference between geometry and feature collection?
Yeah. Any question?
What is the difference between geometry and feature collection when you add the points?
Okay. So in this time here you can see I use here the feature collection in this time. You can see for the water I take the 29 point. Okay. So in this time you can see I use the feature collection because here I take the lot of feature as a point. Okay, and all of the property name will be same, and for 29 training point of water I set the value for the 0. So you can see when I print this, then you can easily understand. So first of all I take the training point, then when I print this, then you can easily understand. Just a minute. So in this time I take the 6. Okay, so I take the another barren land. I use here this band combination. Suppose it's we can easily identify the barren land when I use the 6, 5, 2. Okay, so I simply use here the 6, 6, then 5 and 2 and apply. Okay, so now you can see you can easily identify this type of color, identify the barren land. I set the barren land and take the training point from here. Also I find out the training point here. So now you can see I take the training point for the barren land. Okay, so in this time you can see I take the training point for the water, build up, vegetation and barren land. In this time my fourth step is that I need to merge all of the training point together. I merge all of the training points. So that's why I simply take a variable. Suppose I simply put the variable name is that suppose training. Okay, I put the variable name is a training. So you can use any variable name, training. And then I simply call the water. It merge with build up. Okay, it's merge with vegetation. It merge with land. Okay, in this time I just print this and then check all of the training point. So I simply print and then simply copy the variable name training and click to the run. So now you can see here I can get total 133 training point for all of the classes. I want to check. You can see it's numbering from 0 to 132. 0 to 132. All of the training point I want to get from here. So in this time when I click to here, suppose this click, I simply, you can see property, class 0. So in this time, this training point is 0. Class is 0. It means that this training point I take for water body. Okay. Because you can see when I set the value 0, for water I set the value 0. Suppose I want to check the another value, suppose 61 training point. What's the, you can see class 1. So this 61 number of training point I use for get the training point for the build up area. Okay, because I use here the, you can see 1. Okay, so all of the training point I can get their classes. I can get their classes. All of the training point I get, I add their classes. You can see for the 3. So 130 number training point, it's provide, I take the training point for the class 3, and class 3 is that barren land. Okay, so all of the training point I provide their class. Okay, so any question in this time in here? Any question?
It's okay.
Any question in here for the getting the training point?
I don't know why did you merge all the points together.
So your voice is very slow and
Okay. Uh, do you hear me well like that?
okay. So you can see in this time I will again explain. So it's a supervised classification method. In this time I try to show you the supervised classification method. And mainly when you want to use the supervised classification method, then we need to set the training point. Okay. So in this time you can see I take the training point for all of the classes. So I already know this is the water body. Okay, you can see I take the training point for the water body because I already know about that. I can get here the water. I take the training point for the build up area because I already know here I can get the build up area. I take the training point for the vegetation because I already know about that this place I can get the vegetation. I take the barren land because I already know this place is that barren land. Okay, so in this time I take the training point. My main target is that all of the point I create the spectral signature of the band value. I take the band value for the water body, I take the band value for the build up area, I take the band value for the vegetation, I take the band value for the barren land. Okay, then I use here the machine learning method. Then when the band value, suppose I take the water body band value from this region, but when this band value, when this pixel value is the similar
I
for the other region,
wait.
it's automatically identify this is the water body. Okay,
Okay, I understand this part very well, but I don't know why did you merge the points, the training points. What is the idea behind you merge these points?
yeah, please. Your voice is very slow. Okay, so I think some problem in your microphone. I increasing the value, but
Okay, I will
if
write the question.
if possible, you can simply text me in my WhatsApp or in here. Then it's a bit. Okay, okay. In this time, my main target is that I create the training pixel value. I get the all of the point pixel value. I merge. My main target is that I need to create a data set. I need to create the spectral signature all of the point. Okay, so you can see I create the merge all of the training point and get the one variable. Okay, so in this time I use this one variable. I can easily make the training data set. Okay, so you can see I take the training data set, then you can easily find out this solution. So I merge all of the training point and storing in a variable training. Okay, so that's why when I create the training data set, I take the band value, then I can easily get all of the training point band value. Okay, and I already classified, you can see 124. What is the training point? You can see this training point is that class 3. Okay, I already classified all of the training point. Okay, so in this time I merge all of the training point. That's why I can easily get all of the point pixel value of band. So in this time I need to create a band. So which band value I want to use in this time? So in this time I simply take a variable. You can see I simply take a variable, put the variable name is the suppose bands, and now I make a list all of the bands. Suppose I need the pixel value for B1 band, then B2, then B3, then B4, and then I also use the band value for B5, B6, suppose B7, P7. Okay, so in this time my target is that B1, B2, B all of the band for total 133 point. Okay, each point I want to need all of the band value. Suppose 0 number training point. For this training point I want to need all of the band value. For this training point I need all of the band value. For this point I need all of the band value. For this point I need all of the band value, and up to 133, 132, all of the point I need all of the band values. Okay, so that's why at the same time so that I can get at the same time all of the band value, so that's why I simply merge all of the training point. Okay, and storing in a one variable. So in this time when I use the variable, you can see at the same time I get all of the band value for single point. Suppose it's a single point. Okay, for this single point I want to need all of the band value. For this single point I want to need all of the band value. So every single point I want to need all of the band value which I add in here. Okay, and get the training data set. Okay, so in this time I create my training data set. So for the training the data set, I simply take a variable. Suppose this variable name, I simply put the variable name is the train image. You can put any name, no problem. And then I simply call my image. You can see this is my image. I simply copy because I use this image. I use this image for getting all of the pixel value. I simply copy the variable name. Okay, then I need to select function and select the all of the band. So all of the band is stored in a variable bands. I simply copy and paste. After this I need to use a function. It's called the sample regions. So sample regions. So mainly sample regions provide you all of the band values. So you can see, simply press Ctrl space, you can get all of the argument. In this time I simply make a dictionary, curly bracket start, as well as also curly bracket int, and then first of all the collection. So collection is that which point you want to need this 10 pixel value. Okay, which point. You can see I already merge all of the training point. I simply copy all of the training point, merge, and storing this variable. I simply copy and paste here. Okay, then properties. So properties is that your property name. You can see when I use here the property is the class. So property is the same for all of the things. So in this time you can see it's showing the properties. So that's why I need to use here the square bracket, because it's showing the properties, not property. It's showing the properties. Okay, so that's why I simply use here the square bracket, and then I simply use here the property name class. Okay, then scale. Scale is the resolution of the satellite image, 30-meter resolution. Okay, so all of the things I simply remove. It's not needed for this time. So in this time I simply print my training data set. I simply print this training data set. I simply copy the train image and click to the run. You can check the training data set. My main target is that I need to create all of the point. For each point I need all of the band value. You can see here I can get total 133, and I want to check for, you can see from the properties, suppose 0 number point, number of 0, I want to click to here. You can see properties, I get all of the band value. Okay, also get their class. So I get all of the band value for this point 0. When I click to here, you can see I can get all of the band value with their class. Okay, so all of the band value I created. So it's my training data set. You can see I get all of the band value. It's called the spectral signature value or band value or pixel value for each point. I get all of the total 133 training point. I get all of the band value. Okay, so this is my training data set. In this time I use this data set for classify my image. Okay, so if you have any question about the making the training data set, any question?
No, it's okay. Thanks.
Okay. So in this time I get my training data set. I use the training data set, and you can see my training data set is stored in this variable train image. Okay, so this train image is storing my all of the training data set. I can get all of the band value, all of the pixel band value. Okay, so in this time I want to, okay, so in this time, okay, so in this time there is a lot of way for check the accuracy. Okay, so sometimes if you want, you can use there the 70% data set for train your model and 30% data set for check your accuracy. Okay, so mainly accuracy for the checking the model is good or bad. So here I use the model, suppose classification and regression trees model. Then I need to check this model is good or bad. What's the accuracy of this model? So for this, you can see I need to check the accuracy. So sometimes if you want, you can use here the 80% data for train your model and 20% data for check your validation or check your testing result. So in this time you can see this is my full data set. Okay, this full data set, from the full data set I take the randomly 80% data for train my model and 20% data for checking my validation. Okay, so let's go. So for this, randomly I take the randomly, not selectively. So here the total 133 training point. Okay, and all of the data set I want to create it in here, all of the band pixel value for each point. My main target is that I take the training point, I take the data set randomly, not selectively. So that's why I need to use a function. It's called a random column. So in this time I take the variable, suppose train data. Okay, and then I simply call the train image, simply copy the variable name and use here, and then I simply use a function. It's called the random column because I take the data set randomly, not selectively. I simply use here the random column, random column. Okay, so in this time you can see this variable stored all of the data set randomly. In this time here I can get from this data set, I want to get 80% data and 20% data. So 80% data for check your train your model and 20% data for check your validation. So let's go. So 80%. So I take a variable and give the variable name is the suppose train set. Okay, then I simply call the train data because it all of the data set now randomly arranged in this variable. I simply copy and paste here and use a function. It's I use at the filter, and then I simply use at the ee dot filter dot less than. I take the randomly 0.8, and the same things for the testing data set. I take the another variable, so I simply copy this variable name. Let's simply copy this code again and paste here, and then I simply use here this I simply use here the test set. Okay, after the test set, and I need to use here the greater than or equal. So I simply use here the greater than or equal. Okay, so now I've divided the dataset the two way. In this time I need to create my classification model. So here you can simply search here. Here you can get all of the classification model. You can see I simply search there the classifier. Okay, so here you can see all of the classifier is available here, and in this course I also try to discuss all of the classifier. No problem. For I try to discuss about that support vector machine, how it will be work, classification regression trees, how it will be work, minimum distance, how it will be work, then random forest, how it will be work. So I try to show you all of the process step by step. Okay, so today I try to show you only for this how you can use this classifier. Okay, but it has also some statistical purpose or statistical term in here. So we also try to discuss our next class or on user class. Okay, so in this time suppose I want to use this classifier. So classification and regression trees. Okay, in this time I just use this classifier, but I not discuss about that how it will be work. Okay, So but next class I also try to show you all of the process, how it will be work for the classification regression trees, how it will be work for the support vector machine, how it will be work for the decision trees, minimum distance, support vector machine, how it will be work. So next class we also try to show you all of the part step by step. So in this time I just simply copy this model, and I simply take a variable. Suppose this variable name is the classifier. You can use any variable name. After this I simply paste here, and then I simply remove the mean population as well as max node. It's not need for this time. In this time, this is my classifier. Classifier is classification and regression trees. Okay, I use this classification and regression trees model, and I train my 80% data set. I simply use that the train function. So train. Okay, then you can check all of the argument I want to get from here. I want to make a dictionary for put all of the argument one by one. So make a dictionary. Also make a curly bracket in here. First of all, feature. So feature in this time your train set data. So I simply copy the train set and paste here. Okay. Then class property. So class property is that your property name. So class property is that property name. Here you can see when I want to get the property, you can see I use here the class. Okay. In this time you did not use here the square bracket. Simply put here the class. No problem. You can see first time when I work with the properties, you can see this. Then I need to use here the square bracket. In this time you can see it's the property. So that I simply use here this name. No problem. In this time input properties, so I simply put here the input properties is that all of the band, and all of the band I already stored it in a variable bands. I simply copy the bands and paste here. Okay, then it's not needed for this time. I simply remove. Okay, so this is my classification model. Okay, I use here the classification and regression trees, and then I train my data set. Okay, then I just classify my satellite image. So for this, in this time you can see this is the classifier. Okay, so this is the classifier. Okay, so just a minute, I have an urgent phone, then we also try to continue again. Okay, just a minute.